Okay, this is topic 7, part 1, finding the line of best fit. So we're first going to talk about what is the line of best fit. So a line of best fit is described or explained right there. A straight line that best represents the data on a scatter plot. So this line may pass through some of the points, none of the points, or all of the points. The scatter plot below shows the relationship between games played and tickets won. So right here you have tickets won and games played. Okay, so the more you play games, the more tickets you won. Really is what that trend line is going to have a positive correlation. So which one represents the line of best fit? If we look at this first one, okay, you have a lot of points above right here, not as many points below. All right, with this one, again, a lot of points above, some points below, but it's not taking the general turn that the graph is taking, okay, that the points are taking. Whereas this one right here, that line goes in the general direction that the points are headed. You've got a few points above, a few points below, but that line is a pretty good representation, okay? That is a line of best fit. So, next we have, if I can change the page, this one. Okay, sorry. Look at the graph below with the line of best fit already drawn in. Answer the question. So, this line of best fit is already drawn in. You can see it's very close. The points are all pretty close to it. How many dollars did Jim earn for working 5 hours? So if you look at 5 hours, the point, the scatter plot point, is almost directly on the line. So that's about $48. Okay, that is that point right there. Okay, it comes over to be $48. Using your line of fit, predict how many dollars Jim will earn for working 10 hours. So 10 hours is up here, go up to the line, and that is $72. Is the slope of your line of fit positive or negative? Well, we know a positive slope goes upward, so it is, I'll just circle that, positive. And then according to the line of fit, when Jim's hours increase by 5, how much do his earnings increase? So from 0 to 5, it went from 24 to 48. Okay, so 24 up to 48. And then from 5 to 10, it went from 48 to 72. So each time that is adding, if you look at 72 minus 48, that is 24. And then 24 to 48 is also 24. So it's about $24 that is earnings increase. Okay. Next, we have the graph above shows the line of best fit for data collected on the distance bicyclists have remaining in relation to the amount of time they have been riding. So what is the equation of line of best fit? So right here, if you compare all of these, they all have 170 for the y-intercept, which correlates to the graph. Okay, and then 2 have, so let's see, this one and this one have a positive slope, and then this one and this one have a negative slope. So decide, look at the red line. Is that, well, it's not red in yours, sorry, look at that black line. The line right there, the trend line, is that a positive or negative slope? Yes, that's a negative slope, so we're going to cross out the positive options. Okay, so now we've got to decide, is the slope negative 25 or is the slope negative 5/8? Well, let's look at that. If we look, this point right there is pretty much directly on the line. And then again, this point right there looks to be directly on the line. Okay, so I'm going to go with 2, 120 and 6, 20. And we'll find the slope. 20 minus 120 over 6 minus 2 is negative 100 over 4, which is negative 25. So that answer is A. Okay, on this page right here, when you have started this page, what I want you to do is right beside the word below right here, I'd like you to put a little heart, please. Okay, so Here we go. When finding the line of best fit, follow the steps below. Prepare a scatter plot if one is not given to you. Use graph paper. So a lot of times you're going to write your own scatter plots. A lot of times it's given to you, so you never know. Using a ruler, position the ruler so that the plotted points are as close to the ruler as possible. You want to, as I talked about before, you want to have the same number of points above and below the curve, and make sure you're going in the general direction that the curve is going. Number 3, find 2 points that you think will be on the best fit line. So when you're looking at that, those may or may not be data points, but they're points on the line. Okay, so keep that in mind. They may not be points that you plotted, but they have to be on the line. Step 4, you find the slope between the 2 points, and then you write the equation using one of the points in the slope. And you can use point slope form there. Okay, so here's an example. Alright, so the table at the right gives the number of hours. So we're going to do the hours for the x and then the grade for the y. So I'm going with 1, 2, 3, 4, 5. I go up to 5. And then here I'm going to start a break and then start at 60, 70, 80, 90, and 100. Okay, so 3 hours studying is 84, so it's about a little less there. 2 hours, 77. Very hard on this. 5 hours, 92. 1 hour, okay, that's totally my dog snoring right now. I apologize. 1 hour, 70. 0 hours, 60. 4 hours, 90. And 3 hours, 75. Okay, so there's the scatter plot. Now we're going to look at the line of best fit. Now, on this one actually, I can draw a line. Alright, so a line of best fit, it has got to go, okay, I don't like that line. I don't know how to change it. Okay, sorry. That line is not the best. I think I would have gone more that way, but either way, that's fine. Okay, so, that erases my points. Okay, so let's redo that. Okay, so there we go. I'm going to go with my original line I have graphed. So this line right here, you need to pick 2 points that are on the line. So as I'm looking at my line, it really looks like that's a point right there. So 0, 65 looks to be a point. And then the next point, I think that comes close. I'm going to do this one because that looks like it's halfway through. Okay, so that would be 95. Oh, that's hard to tell. So if this is 95, that might be 97, right? Okay, maybe this one would be easier. That's about 92, I would think, on that one. So I'm going to go with 592. Now, what I get for an equation of line of best fit is not going to be what you get for an equation of line of best fit. Alright, because we all draw our lines differently and you pick different points to write the equation. So what we look for is that your slope is generally the same, okay, and that your y-intercept is generally the same, okay, but it's not going to be exact. So the equation for the line of best fit, we actually have a y-intercept, right? And then we need a slope. So we do 92 minus 65 over 5 minus 0. So 92, let's see, that's 25, 26, 27 over 5. So that is 5.4. That is 5.4. So 5.4 is my slope, or 27 fifths, however you want to write it. So I'm actually going to use 27 fifths, and no, I'm going to use 5.4, and I'm going to use a y-intercept of 65. Okay? So y equals 5.4x plus 65. Now, if you had done that in point slope form, we could have used this one and done y minus 92 equals 5.4 times x minus 5. Either way, you do that as 5. Okay? Now, it says predict the grade for a student who studied for 6 hours. You're going to use your equation. All right, so I'm going to use this equation right here. I'm going to plug in 6 for x. So 6 minus 5 is 1. So that's going to be y minus 92 equals 5.4. Add the 92, and that gives me 97.4. That's the predicted grade for a student who studied for 6 hours. Could this line go on forever? No, because you don't get over 100 typically for a grade. Okay, and you only have so many hours in a day to study, right? So that is that's the reason there. All right, now next are there, the next ones are U-tries. So go ahead and do the U-tries, and we'll see you in class tomorrow.